Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about key features of graphs of functions. Alright, in a function, every input, which is your x value, corresponds to exactly one output, which is your y value. Alright, and one way to check when you have the graph of a function, or maybe not a function, to tell if what you're looking at is in fact a function is by using the vertical line test. So if you can draw a vertical line through the graph and it touches at only one spot, then it's a function. If it touches at more than one spot, then it's not a function. So this first example, it touches in two spots where those two pink X's are. So that one would not be a function. The other one, I can draw vertical lines and it touches only at one spot. So that one is a function. No matter where I draw a vertical line, it's only ever going to touch my graph at one spot. All right, x-intercepts and y-intercepts. So the x-intercept is where it crosses the x-axis, and the x-axis is the one that goes side to side. The y-intercept is where it crosses the y-axis, and the y-axis goes up and down. All right. The x-intercept of a graph is the location where the graph crosses the x-axis. The y-intercept of the graph is the location where the graph crosses the y-axis. The x-coordinate of the y-intercept is always 0, and the y-coordinate of the x-intercept is always 0. The x-intercept is the solution, or solutions if it crosses the x-axis more than one spot, to the function. The graph below represents a rock climber's height as she ascends a hill. So, the elevation in feet, elevation is like the height above sea level, and time in seconds. So, the graph next to us, is it linear or nonlinear? So it's linear, which means it makes a line. There's not any curves. And part B, is the graph a function? Explain. So yes, it passes the vertical line test. Anywhere I drew a vertical line through that graph, it would only ever touch my function at one spot. So it is a function. C, what is the y-intercept? And what does the y-intercept represent? So the y-intercept is where it crosses the y-axis, which is right over here at 10. So the y-intercept is x is 0, y is 10, so the ordered pair 0, 10. And that is the height that the climber started. So they started at an elevation of 10 feet. So they were already 10 feet above sea level before they even started climbing the hill. Why would there not be an x-intercept? Okay, so in order for there to be an x-intercept, that graph would have to keep going down. Okay, but that would mean that my time would go backwards into the negatives. And since time cannot be negative, the graph can't extend into that second quadrant. So we can't have that. All right, the graph below represents the path of a golf ball. All right, so the elevation, so how high it gets above the ground, and the distance. All right, so the further the ball is away and how high it goes. So the above graph is linear or nonlinear. So this is nonlinear. It is not a straight line. It has a curve. Is the graph a function? Well, anywhere that I drew a vertical line, it would only touch that graph at one spot. So it passes the vertical line test, which makes it a function. What is the y-intercept? And what does the y-intercept represent? So it's touching the y-axis at 0, 0. And that represents the height at which the ball was hit. Okay, so that means the elevation was 0. The distance was 0. It was hit from being on the ground at an elevation of 0 feet. What are the solutions and what do they represent? So the solutions are where it crosses the x-axis. So it touches the x-axis at 0, 0, and 100, 0. And those represent the horizontal distance that the ball had traveled when it was on the ground. All right, that's it.